People have thought about what life might be like in other worlds for a very long time. That question might finally be able to be answered with the help of the James Webb Space Camera, which is the coolest camera ever made. Proxima Centauri is the nearest star system to Earth. It is only 4 light-years away. Scientists have noticed a few strange things about Proxima B, one of the planets in the system. The smartest people in standard science are shocked by these strange things, which are called artificial lights. But what are they? Are these lights a sign that there is intelligent life on Earth? Come with us as we look into what the James Webb Space Telescope found that could change everything. Strange city lights. We know of no other life besides what lives on Earth. As long as people have lived, they have wondered if there is life in other parts of the world. American scientists Jill Tarter and Thomas Pearson started the search for extraterrestrial intelligence, SETI, project in 1984 so that they could do a search like this between the stars. The nonprofit's goal is to put together radio broadcasts from space. Since radio waves can go farther, the 42 radio telescopes that make up the amazing Allen Telescope Array in the California Sierra Nevada mountains are more likely to pick them up. But in the last 30 years, no clear signal from another planet has been found. After that, the successful launch of the James Webb Space Telescope made it easier to look at a wider range of faint planets orbiting faraway stars. It is the world's biggest telescope, floating about 1 million miles above Earth, and its detectors are very delicate. It could find amazing things that changed the course of history. A very long time ago, no worlds were known to exist outside of our neighborhood. But since then, more than 4,000 exoplanets have been found circling different stars. NASA says that there could be trillions of exoplanets in the universe. Extraterrestrial planets may show early signs of something happening outside of our solar system. While on its way to Jupiter, Galileo turned its equipment back toward Earth and saw a clear sign of plant life. It did this by recognizing the vegetation red edge, which is a biosignature made up of plants reflecting a mix of red and infrared light. For instance, a world like Earth that is covered in jungle should have a strong red edge signal that is easy to see. The James Webb Space Telescope, JWST, will measure the red edge of faraway planets like Earth that are in the habitable zone around stars. This could tell us a lot about what's going on inside the atmosphere of an exoplanet. The JWST might be able to pick up sunlight as it enters a planet's atmosphere when it passes through its star. Spectroscopy would then be used to look at the missing frequencies. Particles and molecules in the atmosphere absorb certain frequencies, making a mark that the JWST can read. Scientists can use this method to find out what's in the atmosphere and if life is possible. Planets about the size of Earth that have atmospheres made of oxygen, nitrogen, and carbon dioxide, like Earth's, could have life. By looking for things that aren't normally found, we might be able to find intelligent life. For example, chemicals used in cleaning goods and refrigerators called chlorofluorocarbons, CFCs, could probably be seen by aliens looking at Earth's atmosphere from far away. It would be a clear sign of technical progress if the JWST found CFCs in the atmospheres of other planets. But it's possible that life on other worlds is nothing like life on Earth. And sometimes even normal living things, like extremophiles, species that can live in conditions where other species would die, can look like they came from another planet. These living things, mostly microbes, can survive in harsh conditions like temperatures of up to 250 degrees Celsius or strong acids with pH levels below 3. It might be best to start by looking at worlds like Earth, which are more likely to have life than planets with very high or low temperatures or acidic environments. These planets might be hot enough for liquid water to exist on their surfaces, and they might also be in a stable orbit around a star. A bright G-type star is what our Sun is. These stars are less common and usually don't last as long. In our galaxy, on the other hand, it is more likely that scientists will study planets that circle red dwarf stars, which are more common stars that are less bright and warmer than the Sun. Because of this longer time frame, life has had more time to grow and evolve, creating more complex organisms. The first job of the JWST will be to study the TRAPPIST-1 star system, which is about 40 light-years away from Earth. It goes around a calm red dwarf star with 7 rocky planets about the size of Earth. 3 of these hard planets could have liquid water on their surfaces because they are in the habitable zone. The TRAPPIST-1 star gives off light that looks a lot like the Sun's. even though it is smaller and has a lower mass than our Sun. Proxima Centauri, a red dwarf star 4.25 light-years from the Sun, is the best place to see city lights outside of our solar system because its planets are close to it. As a planet, Proxima would have to be much closer to the Sun than Earth is to the Sun for life based on liquid water to be possible. Astronomers found a planet with a mass of 1.3 Earth masses in this Goldilocks zone in August 2016. This is a place where the amount of light is just right to melt water. Proxima B goes around Proxima Centauri. But Proxima B could be a world that doesn't have any air and isn't doing anything. It goes around its red dwarf star at a distance of only 4.6 million miles, which puts it in the path of strong solar winds that could wipe out its atmosphere. Still, Proxima B gets enough sunlight for temps and water levels to be like those on Earth. Because it is so close to its star, Proxima B is thought to be tidally locked, which means it always faces the star from the same side, like the Moon does with Earth. Proxima Centauri has about 18% the mass of the Sun and only 5% of the brightness of the Sun's light. The world may look like it's been burned up and is empty. Proxima B, on the other hand, might have liquid water if it has an atmosphere that keeps heat in. Since it only gets 65% of the energy that Earth gets from the Sun, the world might not be a great place for life to thrive. It's still the best choice, though, because it is tidally locked, which means it always faces the same way toward the star. Proxima B experiences permanent day and night with very different temperatures. It also gets almost 4 times as much high-energy radiation as Earth does, such as X-rays and ultraviolet light, because it is so close to Proxima Centauri. Proxima B is also hit by high-energy particles when the Sun bursts. Life might not be able to thrive there if it doesn't have a magnetic field like Earth's. Still, if the conditions are right, Proxima B might become a friendlier place to live. Models indicate that the atmospheres of worlds that are tidally locked may break down quickly because volatile gases on the night side freeze out. The atmosphere of our planet can be renewed by volcanoes. On worlds with strong magnetic fields, the atmosphere is less likely to escape. As of now, we don't know anything about Proxima B's volcanoes or magnetic field, so we can't say for sure if the planet has an atmosphere. But because an atmosphere means there are likely to be seas, and seas and atmospheres together mean there is life, everyone is very interested in finding out if Proxima B has a complex ecosystem. On the day side, there could be filling stations for solar power that would light up and heat the night side, which would be too cold and dark to live in comfortably otherwise. As soon as Proxima B was found, people rushed to find out if it passes the face of its star as seen from Earth. Scientists could use these transits to figure out the planet's size and mass, which would help them guess its density and prove that it is made of rocks, which would give them clues about the materials that cover its surface. It is possible for sunlight to pass through the planet's atmosphere during a transit, but there is only a 1.5% chance that the orbit will be lined up correctly for experts to see a transit. The star's tendency to flash makes things more difficult. David Kipping, an astronomer at Columbia University, says that the star is unstable because solar flares make a hard planet soak up light and send it back out as infrared light. But rocky planets make a certain kind of infrared light that stars like Proxima Centauri can't see. In addition, the James Webb Space Telescope was made to pick up infrared light. Finding Proxima B's infrared signal is important for figuring out what kind of atmosphere it has. The JWST also has much better infrared powers than Hubble. This means it might be able to see city lights on the night side of Proxima B, even if they are as dim as those used on Earth. The JWST could pick up on manufactured light as long as it stays in a frequency range that is much lower than the star's light. On the day side of Proxima B, there may be a lot of solar screens that reflect starlight. As Proxima B goes around its star, it always has day and night, and the temperature changes a lot. The difference in temperature between day and night will depend on how much rock is exposed on the world. If Proxima B doesn't have an atmosphere, the day and night sides will have very different temperatures. We can figure out the exact amount of black body radiation that should be there because the day side will give off all the energy it gets from Proxima Centauri as a black body. On the other hand, the night side would look like a frozen wasteland. If there is less of a difference in temperature between day and night, we can assume that there is an atmosphere. It will only take 11.2 Earth days for the JWST to measure the infrared light coming from both sides of Proxima B. As soon as its trip around the star is over, The next step will be to look at what's in Proxima B's atmosphere if it has one. Gases like oxygen, water vapor, and methane could mean that the area is habitable, even if there are no live things there. To do this, though, we need to be able to catch starlight as it moves through or bounces off the planet's atmosphere, which is a very hard job. The JWST can get a close look at some of the nearest worlds that might have life, but it wasn't specifically built to look for life beyond Earth. It can only keep an eye on changes in the amounts of methane, carbon dioxide, and water vapor in the air. It is impossible for the JWST to find free oxygen, which is the best proof of life. Even though some mixtures of these gases may be signs of life, the extremely large telescope, which is set to start working in the 2020s, is one of the planned ground-based observatories that will be able to do a more in-depth study of the atmosphere. Ozone is one of the things that the JWST might be able to find. The JWST may give us data that we can use for the next 10 years until those other telescopes are ready to use. Also, more advanced space telescopes may use cutting-edge methods to block out the bright light of a planet's host star, showing starlight reflected back from the planet. This is similar to how you can cover a light with your hand to see things farther away. In the future, space telescopes might be able to do this with small covers inside or big umbrella-shaped satellites outside. When sunlight is blocked, it's easier to focus on light reflecting off of a planet. Sadly, most of the gases that living things on Earth make can also be made by things that aren't living. As an example, methane is a gas that is made by both cows and volcanic springs. Photosynthesis is the process by which sunshine changes water molecules into oxygen and hydrogen. Astronomers are bound to find some false hits when they are looking for life beyond Earth. To figure out if a planet's geological or atmospheric processes could look like a biomarker, scientists need to know a lot about that planet. This helps them rule out false results. The next round of planetary research could find the proof that we need to be sure there is life beyond Earth. The groundbreaking data from the James Webb Space Telescope gives us a look at the huge changes that are about to happen. If there is life elsewhere in the universe, it answers one of the most important questions in science. Is it possible that there is a lot of life in the universe, or are we the only ones living on a world in deep space? Any way you look at it, the end of this trip will probably require big changes in the way people think about philosophy or existence. People have been interested in finding life on other planets for hundreds of years, which has led to a huge number of stories and theories. As technology improves, our knowledge of the world grows, opening up more chances for life to exist beyond Earth. Using space telescopes like the James Webb not only makes it easier to find planets far away, but it also lets us study their atmospheres in great detail, which helps scientists look for signs of life. The study of exoplanets also encourages collaboration between well-known scientists and foreign space research groups. This makes it easier to share knowledge and resources, which increases the chances of making important discoveries. The public is also more interested in and involved in space exploration because findings are often shared with a large group of people, which sparks their imagination and curiosity. In the end, the moral implications of finding life in other places will make us think deeply about our own. If we found cultures on other planets, it would change how we think about the point of life. These kinds of questions make us think about our place in the world and how we connect with our home planet. We are getting better at exploring the stars, and each new finding brings us closer to answering the age-old question, are we alone in the universe? The road ahead is full of possibilities that will push our natural limits in our search for knowledge and understanding.